So, good morning gentlemen. Let us start lecture 28. We continue with our topic of load flow analysis. Today we propose to cover Gauss-Seidel method. Load flow problem. What we do, as all of you know, we specify variables 2n at all the buses. We call that as a vector y, and when we solve 2n SLF equations iteratively, because we can't solve them in a closed form manner, for remaining 2n variables are also known once the equations are solved. Finally, we compute line flows followed by losses, because these are very important for many power system studies, so as to see whether line flows are within limits, whether power system security is maintained, whether we are fulfilling the contractual obligations, and losses are within limits. Now, sometimes for planning studies, as I said earlier on, we need an approximate load flow. Say you want to know what happens in 2007 or 8 or something. Planning long term, mid term, short term, very long term. Then we use approximate load flow studies. By approximate, we mean the R is assumed to be 0. That makes losses also 0. So, mainly we are bothered about voltage profile and line flows when losses are 0. And that this R0 makes these both thetas nearly 90 degrees. As it is, theta is close to 90 degree. I told you R is very small, X is very high. So, this angle is as it is close to 90 degree, but when this becomes 0, then the angle becomes 90 degrees. And sine also becomes of delta equal to delta when delta is small. This we have already talked earlier also. Let us assume that all buses are PV when you solve an approximate load flow. That means all voltages are known. The beauty of a PV bus is P and V are known and Q and delta are to be found out. That is the meaning of PV bus. Then our SLF equations get reduced to Pi Qi, Vi sigma, Vk Yik, delta I minus delta k. The sine delta becomes delta, as we have just seen. Qi becomes minus Vi sigma Vk Yik cosine delta I minus delta k. Incidentally, cosine of a small angle is large, cosine 0 becomes 1. So, you can't apply the same theory here that cosine delta when delta is small is delta. No, that is not correct. And plus Vi square Yii for all I varying from 1 to n. So, now we have reduced our SLFE to a set of linear algebraic equations in delta I. Why delta I? Everything else is known. All V's are known because it is PV buses. All Y is known because it is a model of the system, Y bus, and that is all. What is unknown left is deltas. So, once we solve the first equation in delta, substitute here, we get Pi and Qi both. And once you get Pi and Qi, you can find out the slack power P1, which is unknown. So, slack power is known. This is computationally very economical way of solving SLFE, because they become a linear equations. In fact, we do not have to go for iterative solution. It gives you closed form solution, or use Cramer's rule or whatever, and you can straight away solve it. Please solve the example 6.3 of the textbook, which talks about this method, that is approximate method. Then you will realize how easy or how convenient it is to solve an approximate load flow. Obviously, the answers will be approximate using this load flow method, but those answers are indicative of things to come, because in 3 years there is no guarantee what you are assuming today will stay as it is. There will be some changes. So, there is no point in solving SLFE exactly for something in future which is really not defined, well defined. Now, we come to a proper method. In fact, there are 4 load flow methods. Let me list it for you. Different load flow methods. You must have studied only first 2, Gauss-Seidel, Newton-Raphson, decoupled load flow method, fast decoupled load flow method, which is also called FDLF. The fast word goes, then super fast decoupled load flow method. Then there is a second order load flow method. I think we will stop here. These are the various methods which a postgraduate student in load flow should know. You might have done perhaps Gauss-Seidel and Newton-Raphson. Some places maybe you might have done even FDLF, but uniformly I don't think all of you must have done all these methods. So, now Gauss method we need not worry much, because as I told you, Gauss method nobody uses nowadays, because unnecessarily we are not updating the data which you already have. It is a common sense. If you have an updated data, if you know the current temperature at 11:25 AM today, why should you show on TV 8 AM temperature, unless until your aim is to tell viewers what were the morning like. So, that is a separate issue, but when you say current temperature, you should show as much current as you have. And that is why the Gauss-Seidel method becomes the starting point of exact load flow method. We have done approximate a few minutes back. This is needless to say, it goes without saying that it is an iterative method for solving any nonlinear algebraic. It has nothing to do with power systems or electrical engineering or any engineering for that matter. Those of you who have done numerical analysis course, say Hildebrand's book or any book, Jane Angar or whatever book you must have used in your course, if at all you have done that, this Gauss-Seidel method is there. This is nothing to do with electrical engineering. This is a numerical technique which can be used to solve any set of nonlinear algebraic equation. So, we are using it for our purpose. A solution vector is assumed. Any numerical analysis, there are 3 fundamental factors. You may be doing project work after some time, and then you may have to use certain numerical techniques which you may have to use for solving your problem. So, while selecting numerical technique, you had to see so many things, the type of problem, the type of accuracy you need. Suppose you select this Gauss-Seidel, then any numerical technique you may select, you have to assume the initial solution vector, starting point, because it is not known to you. So, a solution vector is assumed and one equation is solved to get revised value of a variable. Immediately solution vector is updated. What I mean here, suppose you have started, let us do it here. Say you have a 4 bus system, V1, V2, V3, V4. Luckily, to start a load flow solution, we know the solution vector which we should start. Why we know? We know that voltages at all the buses are close to 1 per unit. and this is called flat voltage start. You must have learned this term earlier also, I am not sure, but anyway I repeat it, flat voltage start. When you say flat, means we assume that all voltages are 1 plus Z0 or 1 angle 0. So, the initial values of all voltages become 1 plus J0 barring the slack, because their voltage is given to you. So, in fact, I should not assume voltage here, it is given as 1.04. So, there is no 0 here, it is given, because 1 is our slack. So, once you know V2 0, at the end of first iterations it becomes V2 1, and when you calculate V3 0, use this rather than using this old value. This is Gauss-Seidel. Instead of using the earlier solution vector, we immediately update it with the latest values of voltage. When you go for V3 0, we immediately use V2 1. When you go for V4, when you calculate V4 1, then you should use V3 1, V2 1 and V4 0. So, immediately update rather than using 0 0 here. That will make it a Gauss method, and the difference between Gauss and Gauss-Seidel is here we immediately update it till whatever we have already calculated. And after updating the solution vector, process is repeated for all variable, and once you have finished all variables, we say one iteration is over. One of the important point in any numerical technique is when do you stop, otherwise you can go on and on and on. So, you have to stop somewhere. The stop means you have to find out convergence criterion. Let us see what sort of convergence criterion we have. Same thing I am writing here. Iterative process is repeated till solution vector converges, and let me tell you, convergence is very sensitive to starting values in some techniques. Depending on your starting values, number of iterations will change. If you are not an intelligent person and you start the values of voltages as 0 plus J0, perhaps you may not converge, you will diverge, because you do not know your system, you do not have a common sense to understand that voltages 0 means it is a very bad system. It has to be close to 1, and that is why we always start our Gauss-Seidel or any method of load flow by 1 plus J0 called flat voltage start. Assume slack plus all PQ buses the voltages. Now, you know the current is equal to Pi minus jQi over Vi star. This equation is known to us. P is equal to Vi conjugate. From there we have derived this. This equation also we know Vi is equal to 1 over Ii into Yv. This is nothing but Ohm's law. V is equal to IV, and then for I we are substituting this. Is this equation clear to you or no? This is nothing but, let me tell you a very simple equation, J is equal to Vy. Now, I have broken this V into two parts. I have taken Yi and Vi this side and rest this side, and this is nothing but Ji, right. Now, what I do? I substitute in Ji this equation. Moment I do this, because I do not want current at all, moment I do this, I get this final equation. Now you will see that there is no current here anywhere, because in our load flow variables there is no current, it is P, Q, V delta. So, we must bring our load flow equation in these 4 quantities. Now, Vi can be found out by 1 Yi Pi minus jqi Vi star minus k is equal to 1 to n, k not equal to I, because ki has gone this way. You already shifted it to left hand side. So, it is not equal to I, Yik Vk, I is equal to 2 to n, assuming all are PQ buses. If you recall, for approximate solution, we assumed all were PV buses, it suited us, because we did not want voltage to be an unknown variable. The moment voltage becomes unknown variable, they don't remain linear equations, they become non-linear equations. Z is equal to x y is a non-linear equation if an x and y both are variables. But here we are just opposite, which is close to reality. If you remember, I told you that 85% buses are PQ, 15% buses are PV, because there are not many generators. Where is the money and where is the need? So, one is slack, 15% roughly are PV, and then remaining are PQ. So, this assumption is more close or closer to reality. Now, we find out Pi and Qi at 2 to n, that is for n minus 1 equations. Find means, by find I mean, since you know load, since you know generation, so generation minus load becomes Pi, in that sense find. Otherwise, they are supposed to be specified, but before specify you have to find out from somewhere. Either you think or you get it from the old data for which system we closed yesterday. See, in running power system, you do not have to worry about the initial starting solution, because it is already there. You know, after all, the Badarpur has been working for last so many years. So, last night when you close the system, or if you when you left, the system is never closed. When you left the office, what was the, or what is the latest on computer, and that you can put it here, that is Pi Qi. If it is a theoretical exercise or a planning exercise, then you have to find, because then you are assuming what is the generation, what is the load which will come on that, then Pgi minus Pdi becomes Pi. Assemble Y bus. I have already told you 2 methods of assembling Y bus. One was simple rules, other was by singular transformation, that is Y is equal to A transpose small y into A, where A is a bus incidence matrix and small y is a primitive admittance matrix, which is a diagonal matrix. Having assembled Y bus, again for a working system, you do not have to do this again and again, unless until there is a change in Y bus. That means there is a change in topology. That means either a new node is added, or an existing node is removed, or a new line is added, Y bus will remain same, it will not change, right. But in theory, for a classroom, you have to write to the student assemble Y bus, in case it is not done earlier. Iterative computation of bus voltages use flat voltage start. I already explained you what is flat voltage start. Flat voltage start is V01 plus J0. Now, Vi can be expressed in rectangular coordinates or in a polar coordinates. Both have plus and minus. What is the plus point here? Ei plus Jfi, the rectangular version, at times give better convergence, but this is more practical. What you can measure is a magnitude by voltmeter, what you actually get is an angle. So, this is more practical and this is more, it is convergence wise, it is slightly better. Advanced operations, no change. Now, this is a basic, the meaning of this last sentence is very simple. All of you must have studied computers now, maybe in your school days or primary school or middle school or high school, I don't know. The first sentence or first thing which is taught to students is whatever remains constant, that mathematical operation or arithmetic operation you should not put in a iterative loop, because otherwise you are doing it again and again unnecessarily. Say you have to divide 4 by 2, the answer is 2. This division should not be done 100 times. If you take 100 iterations, it is already known 4 divided by 2 is 2. So, do it outside the loop. That is why some of the operations in this equation which are fixed should not be put in the loop, iterative loop. That is what is the meaning of this. Carry out this operation in advance where no change is likely to take place. That will save you computer time. In our days, we were told division takes more time than multiplication. I don't know whether things have changed in last, because we were taught computers in 60s. At that time we were told, you will correct me if there is any change, if you have to write a divided by 2 dot to make it real variable, it is better to write a into 0.5. This takes less time than this. Whether it is still true or not, you will tell me. So, do not write such a statement, write such a statement where the multiplication is easier. Similarly, I do not know whether this is true now, a square should be written as a. Maybe this this operation takes more time, I do not know. This way we were taught in 60s. Right. These are the two quantities which came, which are part of that equation. Pi minus jqi are known to us for all PQ buses. In fact, they are specified by us. They are not going to change. Divide by yii, this yi is not going to change. I have already talked to you in 2 minutes how y bus remains constant unless until there is a change in topology. So, why this particular factor should be a part of loop? So, call it ai and compute it once and for all buses, all PQ buses. Similarly, we call it bik, yik divided by yi. This division takes a lot of time, as I told you, and so why not divide it once and for all and keep it as bik, and that is why that equation now becomes this ai over vir star minus sigma this and this. This sigma I am breaking into 2 parts because of Gauss-Seidel. This is already ai, right. Similarly, this divided by this is bi. That is why I am now breaking this equation into these parts. You are suppose at 4th bus. That means, first 3 buses you have the latest values r plus 1th iteration. Rth iteration you have 4th bus, because you are at the 4th bus now. That is why I have separated these sigma into 2. So, this is the latest values you calculate, here you calculate the originally assumed values, which is 1 plus j 0. But here you will put the exact values which we have got. And how long you will iterate it? Till the voltage difference between immediate past 2 iterations becomes less than epsilon. And how do you define epsilon? It depends how much accuracy you desire to have for your system. If you are very fussy, 10 to the power minus 4, 10 to the power minus 5, 6. If you say no, these are all rough calculations, planning calculations, then even 10 to the power minus 2 is okay, minus 1 is okay, and so on. It depends on the desired accuracy. That means the purpose for which you are conducting load flow. As I have repeatedly said, load flow is required practically in all power system studies, be it stability, be it the economic operation, be it security, or what fault studies or whatever. These things will be more clear when you solve a numerical. How do you compute slack bus power? Once you know all voltages, you already iterations are over, you have converged. Just substitute S1 star is equal to P1 minus JQ1 equal to whatever equations those two are there. Substitute the final converged values of voltages, you get the slack power, because that was unknown. P1 and Q1 were not known. So now you know the P1 and Q1. Now we must compute line flows. I told you line flows are very important. How do you compute line flows? You have to give a model of a line. This is bus I, this is bus K. This may be Panipat, this may be Karnal. They are connected by a line. Now this transmission line can be modeled by a short line, but it is not a short line. If it is more than 100 kilometers, it is not a short line. And if it is less than 100 kilometer, yes, it is a short line. Then you need only a series impedance. Assume that you are going from, let us say, Delhi to Chandigarh, which is definitely not a short line. It is about more than 5 hours journey or so. So it must be 250 kilometers or 300 kilometers or whatever kilometers. It is definitely more than 100 kilometers. So we represent either by pi or t. Now can you tell me which model is better? Pi is better or t is better? Both can represent, in fact they are called nominal pi and nominal t. Both can represent medium line. Similarly, both can represent long line if you talk of equivalent pi and equivalent t, where you use hyperbolic cosine and hyperbolic sine. Okay, that ABCD constants, this which you must have done in your undergraduate. This has been conclusively proved that pi model is better than t. So we are not talking about t, I have drawn a pi model. Why pi is better than t? I have already talked to you perhaps that pi, the shunt branches can be connected to the load, combined with the load, then the number of nodes are fewer here than t. T has a middle node which you cannot replace, you cannot ignore. So there is a problem with t. Otherwise T is fine, there is nothing wrong with t. So we prefer pi model in load flow analysis. So this is bus I, this is bus K, this is Vi the bus voltage, this is Vk bus voltage, the power, the complex power which is coming to the network is Sik, from here it is Ski, this is a current Iik, this is a part of the current Iik is 1 going to the series branch, the Iik 0 going to the shunt branch. Similarly here also the current going is Iki 0 and here Iki, and this is Yki is 0 is the shunt branch, Yik is the series branch. So this is a pi representation of line plus transformer, both connected between two buses. Now once you know this figure, right, then you can write equations and ultimately you can find out an equation for line flows. What are those equations? Now keep this figure in mind. I don't know how to put both of them together, but anyway, Iik, apply KCL. Apply KCL at this point. So this Iik is equal to sum of these two currents. That is why I am doing it here, is sum of these two currents. How do you find out this current? Very simple, Ohm's law, Vy. So this is Vi minus Vk Yik plus Vi Yik 0. So, as I said, I do not like current at all in electrical engineering. So, I am replacing current into always into voltages and Y or Z. So, I have done that. Once you do that, then you know the line flow Sik is nothing but real line flow, real power flow plus reactive power flow. So, that is Vi Iik star. We have just found out Iik. Substitute. Star means you have to change here anything which has come. So, make it star, star, star wherever there is no star. Similarly, find out Ski, same way. Now, you know the line flows Sik and Ski, these are the two line flows. Sik is flowing from I to k and Ski is flowing from k to I. Suppose you add them, what you will get? Ideally, you should get 0, but there are losses. So, in case you want to find out losses in this line, add these two line flows, whatever you get is the loss in that line. Suppose you want to know losses in all the lines, what do you do? Sum all the line flows, sigma of Sik for all I and k is nothing but SL, complex losses, PL plus JQL. Normally, you are more bothered about PL. So, you can take a real part of this and you get the PL. So, PL plus JQL is summation of, same thing, it is already there for all. This ulta A, inverted A is what? For all I and k. S1, suppose you want to know the slack power, there is an alternative way of knowing slack power if you know line flows. Add all the line flows emanating from slack bus. Suppose this is a slack bus and there are 3 lines, add these 3 line flows, that is nothing but slack bus power. So, this is what is written here, S1 is sigma line flows terminating at the slack bus. Now, there are certain people who want to accelerate convergence. See, why do you think there are chaos on Delhi roads? Everybody wants to reach his or her destination first, and that is why there are no lane system in India. If you go any foreign country, beautifully cars are coming, it looks so nice one after another. Whatever speed, 100 kilometer or 100 miles per hour, they go smoothly. First thing is, here there are not only cars, there is a car, there is an auto, there is a two-wheeler, varieties of two-wheeler, then there is a cycle rickshaw, then there is even buffaloes on the road sometimes. So, all sorts, even people are walking in the middle of the road, they create their own way. So, that is why it is real challenge to drive on Indian roads, and therefore, there are problems because everybody wants to be ahead of everybody else. So, in power system also there are some people who want to have fast convergence, they cannot wait, they have no patience. So, acceleration of convergence, there is a formula, Vi r plus 1th accelerated value is Vi rth value plus alpha times the difference between the two iterative values of the voltages. Now, this alpha does the trick. Alpha is called acceleration factor. Unfortunately, I can't write everything on the slide, the space is limited, plus I write it with my own hand. Normally, people get typed. I think you do not attend anybody else's class. The earlier class, the gentleman must have typed it. That gives you more uniform, beautiful lines, but I write. Now, this alpha is called acceleration factor. Now, there is another problem. What is the problem? There are problems and problems in life. Do not think life is without problem, whether you are prime minister or you are a class 4. There are problems, and all of you know what problems he is facing. Our problem is how to assume the value of alpha. You have given me a method to accelerate the convergence, fine, but how do I assume? It is a $1 million question. And mind it, if you assume a wrong value, instead of giving you faster convergence, it gives you slower convergence, sometimes divergence. Like if you take too much of vitamins, do not think it will do good to you. There is a limit, there is a constraint. Now you know the word constraint. So if you assume a bad value, wrong value of alpha, you had it, instead of getting convergence, you will get slower convergence, or instead of getting faster convergence, either you get slower convergence or you get divergence. The normal recommended value of alpha is 1.6, like every medicine bottle there are recommended dose, and finally he says consult your doctor, so that he is safe. Suppose tomorrow somebody dies, you can't go to court because he has written there one line, small letters which nobody can write, like all statutory warning on cigarette packets, so small that even a 16-year-old boy with good eyes cannot read it, because they are only fulfilling the legal requirement. They actually do not want people to read that. So similarly here, it is recommended value of alpha is 1.6, hopefully you will get convergence. Now we come to the reality. In reality, all are not PQ buses. You have nicely assumed all are PQ buses to make your life simpler, happier. Always person wants path of least resistance in our daily life. When PV buses are also present, which is a reality, PV buses are always there, indeed there. So QI becomes unknown. So how do you find out QI now? Minus imaginary values of Vi cross sigma k is equal to 1 to n, Yin and Vk. This equation we know. Now again I am divided this into two parts, up to I minus 1th buses, because I know the updated values, upgraded values, new values, whatever you want to call it, and these are old our solution vector. Once you know Qi, you can find out delta I also, just an angle of VIR plus 1. So this is the old friend VIR plus 1, take an angle of that and you know delta I. Here AIR plus 1 is Pi minus JQIR plus 1. Why Pi? There is no superscript, because Pi is known. Whether it is a PV bus or is a PQ bus, P is common to them. That means P is always specified in a load flow studies, except slack bus, where P is not known till the end. Now you know very well why it is not known till the end. So now we have generalized Gauss-Seidel load flow method we have covered. We have covered when there is an approximate load flow. We have also covered when there is only PQ buses. We also covered when there is a PV buses also present. But mind one thing, when you get these values of Qs here, you have to remember one thing, check whether they are within constraints. After all, Q is being supplied by either synchronous converter or a bank of capacitors or a bank of inductors. Now you do not have infinite capacitance with you, you do not have, even the wealthiest country in the world, US, has a constraint on Q in its power system. So this Q has to be checked by if statement. I do not know which language you write, I only know Fortran, so I used to write only if statement. So check if Q is between Q min and Q max. If it is, have a coffee break. You can go to Kishan Lal or wherever, have coffee or tea, whichever you like. If not, if violates, luckily here nature also helps you. This is Q max and this is Q min. Q can either lie inside or outside, but outside means either it can cross upper limit or lower limit, not both simultaneously. You are either in the studio or you are outside. You can't be both. Only God is omnipresent. That too nobody knows. Nobody has seen God. It's only perception. So here the reality is either Q crosses upper limit or Q crosses lower limit. It cannot cross both simultaneously at the same time. So whichever violations take place, make it equal to Q min or Q max. And this PV bus gets converted into PQ bus as long as there are violations. The moment violations go away, the bus is converted back to PV bus. This is something which is very important to understand. Please mind it, same thing happens in PQ bus also. The voltage which you have calculated, if it crosses V min and V max, similar thing you may have to do, and the bus type change from PQ to PV. Flow chart for the whole thing is given in figure 6.9. I thought there is no point in wasting time here in drawing the flow chart. It won't have come in this A4 size sheet anyway, and I don't know the mechanism or technology of showing you a bigger chart. Perhaps I had to understand from them. We are still in a infancy. I mean, I thought I could go whenever I want to the board, I could go whenever I want here, or PowerPoint or something. I don't know whether it's possible. Of course, more work is needed. I am willing to do that, but perhaps if technology permits that. Now there is example 6.4. Kindly solve that example. Example 6.5, and this is the bus data given to you. Then V21 calculate, V23, V41, and so on, and complete the problem. And when we meet next Tuesday, I assume that you will be able to solve this problem. Anyway, thank you very much.